To solve these inequalities then, we want to use a graphing tool. So in this case, we're going to use our graphing tool to draw our two graphs. So we recognize that we have a linear system here. There's a linear graph, so we have a slope of 2. It goes to the origin. It's a solid line because we are equal to. For the parabola, we have a vertex at -3. Okay, we have kind of a more narrow parabola, and it's going to be dotted because it is not equal to the boundary line. So to show the solution then, we want to show that we're looking at areas below this line and above this line. Okay, so above the parabola, below the linear equation represents that solution. So we also want to test two coordinates that will satisfy the inequality. So you have to recognize where we have coordinates. So it looks like, if you look closely, there is a coordinate here at 1, 0. Okay, so I'm going to test 1 and 0. Okay, so this is my first test. X equals 1, y equals 0. So I plug it into the equation, y equals 0. And x equals 1, that works for the linear equation. For y equals 0 and x equals 1, we end up with 2 minus 3, and 0 is bigger than -1, so it works for both. So that's our first test. And again, we have to test it in both equations, both inequalities. So looking at this then, now I also see that there's a coordinate here on the axes. And again, the axes seem to be the easier ones to identify. And it's easier to count because they usually have grid markings along the axes. So there's another coordinate at 0, -2. So I'll plug that in. So -2 is less than or equal to 0. That works for the first inequality. -2 is greater than, so plug it in there, -2 times 0 minus 3 is -3. -2 is definitely bigger than -3, so it works for both. So whenever I have the opportunity to use 0, I try to use 0 because zeros are easy to calculate. So for the next graph, the next system, I want to graph two parabolas. Okay, so when I graph those two parabolas, my parabolas, I'm going to have one upside down parabola and one right side up parabola. So when I graph that upside down parabola, I do probably want to make sure that I recognize where the vertex is. Okay, so the vertex looks like using, I can use Viete's formula or something like that, but the vertex is at 1.5 and 6.25, and it's upside down. Okay, so it's going to look something like this. And again, 1.5, 6.25 represents the vertex. And I can put in a couple symmetrical points here at 4 and 4 here. So that coordinate looks like it's going to be at 3 and 4. And then the second, and this is, maybe I'll just highlight it. So that's my red graph. And then for the right side up parabola, I'm going to use you can see that it's right side up, and it has intercepts at -1 and +3, somewhere around here. And again, the vertex we should find the vertex. Looks like the vertex is going to be at +1, and +1, -4 would represent the vertex. Maybe somewhere around here. Okay, so then it's going to be a solid line. That's not the greatest graph, but there it is. Okay, and then we want to find the solution region. The solution region is going to be above the green line and above the red line. Okay, so that area that we're looking for above and above should be represented by this space in here. So there's our solution region. Okay, so when I test a point. So I'm going to test. I'm going to test two coordinates. So my first coordinate I'm going to test along the axis, the y-axis. So it looks like if I choose 1 and maybe 0 and 6, that looks like a solution in the solution region. So I plug that in. 6 is greater than 0 plus 4, so 6 is greater than 4. That works. I test it in the second equation. Y equals 6. 6 is greater than or equal to, when I plug the zeros in, I get negative 3 times 1. And yet 6 is definitely bigger than negative 3. So that works. So choosing a second coordinate, I'm just going to choose another coordinate. And I'm going to choose a coordinate over here. So I'm just going to choose maybe at 1, and I know that has to be at least 7. Because I know that's my vertex at 6.25. So I'm just going to choose 1 and 7. 1, 7, plug it in. 7 is greater than, so negative 1 plus 3 plus 4. Looks like 7 is greater than 6. That works. Plug it into the second equation. 7 is greater than or equal to. If I plug 1 in here, I get 2 times 2, so negative 4. That's where the vertex was. Yeah, that's definitely above. So those two coordinates, I'm going to choose that other coordinate was right here. Those two coordinates were look like they were in the solution region. And in fact, when we test it, they work in both inequalities, and they have to. So if they don't work, then those coordinates could not be part of the solution region, which means we got the solution region wrong.